This is a fully functional handheld ZX Spectrum called the Pico ZX. Not only does it run Spectrum applications and games, but it also has some other interesting tricks up its sleeves. Today, we're going to take a look at this really neat device. I'm going to show you how to build one, and then we're going to examine some of the really interesting things that it can do. If you grew up in the United States like me, you may not be too familiar with the name Clive Sinclair. But if you lived on the other side of the pond in England, Clive Sinclair was a household name, particularly if you were on the cutting edge of technology.
The inventor Sir Clive Sinclair has launched his latest creation, an electric bicycle. Undaunted by the failure of his C5 electric car, Sir Clive has come up with the ZX. It has a battery-powered motor and a top speed of 12 miles an hour.
One of his greatest accomplishments of the era was making affordable home computers, and the Sinclair ZX Spectrum was one of his crowning achievements. The ZX Spectrum entered the market in 1982 and was competitively priced at £125, which was roughly around $200 US. This low entry price meant that many families could actually afford to have one in their home. In fact, over 5 million units sold during its lifetime, which makes it a very successful endeavor. But I live in the US, and I was only a toddler at this time, so I wasn't even really aware of the ZX Spectrum. Now, we did actually have some of Sinclair's products sold here in the States, but they were actually quite different than the ones sold in the UK. One example is the Timex Sinclair 1000. This was basically a Sinclair ZX81, but modified for NTSC televisions. We also got the Timex Sinclair 1500 here, which looks an awful lot like the ZX Spectrum. But looks can be deceiving because other than the similarities in the case and the keyboard, this machine is really just an upgraded ZX81. But the one machine that we did get, which was based on the Spectrum's architecture, is the Timex Sinclair 2068. Now, the ZX Spectrum itself actually didn't pass FCC regulations here in the US, so Timex had to modify it. And the 2068 is what came out as a result.
If you've been dreaming of a home computer this year, Timex has exactly what you need. A state-of-the-art 48K color home computer at a very affordable price.
Even though I've never had a ZX Spectrum or a Timex Sinclair 2068, I've always been intrigued by these machines. So I've taken to playing with them over the years using emulators. But recently, I came across a Spectrum emulator project on Hackaday called the Pico ZX. This was created by a maker named Peter Misenko, who goes by the online handle Bobricius. The Pico ZX is a handheld ZX Spectrum emulator that runs on a Raspberry Pi Pico, and it's absolutely amazing. If you're not familiar with it, the Raspberry Pi Pico isn't the same thing as a standard Raspberry Pi. The Raspberry Pi is a single board computer, and it usually runs an operating system that's some variant of Linux. But the Pico is a microcontroller that's based on a chip called the RP2040. It has a 133 MHz processor, which is very overclockable, a couple dozen GPIO pins, built-in DMA support, and lots of other great features that make it attractive for projects like this. But the killer feature is the price, because all this costs a meager $4. Unless, of course, you want the version that has Wi-Fi built in. Then the price skyrockets to $6. Since the Pico doesn't have an operating system, it runs a bare metal version of a ZX Spectrum emulator, which in itself is an interesting project. Now, there's actually a few different variants of this device, and we're going to make two of them in this video. Now, I'm going to be jumping around a little bit, so here's how this will work. First, I'm going to take you through a build of the slim version of this device. This is simply the Pico ZX with no external accessories. So if you build the slim version, you'll have a fully functional ZX Spectrum emulator that you can take with you and play on the go. After that, we're going to build the full version, which adds ports for an external VGA monitor and an external joystick. Now obviously the full version will require more parts, and the device will be a little bit thicker. So if you don't care about the external display and joystick, then you can just stick with the slim version. After we get these devices built, I'll show you how they work. Then if you stick it out to the end of this video, I'm going to show you something really cool about this project that might be the thing that puts you over the fence and entices you to build one. Before we jump into this build, I want you to know that the boards I'm using for this project were provided by today's sponsor, PCBWay. One of the things I just love about PCBWay is how much they support the maker and retro computing communities. Did you know that each year PCBWay hosts an electronics design competition? That's right, you can enter the contest with your own design and win cash prizes and other cool merchandise. In fact, the Pico ZX that we're building today in this video was actually entered into their 6th annual competition, which runs through the beginning of 2024. Now, this is really cool. You can go check out the entries for this competition, and if you find a project that you want to build, you can order the boards for it right from the project page, which is exactly what I did for the Pico ZX. And when you order from the project page, PCBWay sends a percentage of the sales proceeds to the project designer. So by purchasing the boards from PCBWay, you're not only getting high quality boards, but you're also supporting the folks that designed them. There are links to the Pico ZX's PCBWay project page in the description below. So you can go straight there and order some boards and build out this project for yourself. All right, let's take a look at what we need for this build. Starting off with the PCBs, there are 3 large rectangular boards and also 4 shorter ones. As you can see, this device is actually constructed from PCBs. The main board is this one, and it's what the Pico and most of the parts get soldered onto. But you also have a faceplate, which is really just a cosmetic protective piece that doesn't have any components. And you also have a backplate, which holds the battery and the charge controller. The other 4 PCBs are the side pieces. These pieces frame the outside of the device when everything is sandwiched together. The screen for this project is a 2.8-inch IPS display from AliExpress. It has a thin ribbon cable that you'll solder directly onto the board. I've included links to each of the parts in this video's description, but when you order the screen, make sure you get the one with the model number IPS HC28010-D. As you can see here, there are a few different LCD options from this seller, so you don't want to accidentally buy the wrong one. When I first purchased these screens, I mistakenly bought the ones labeled TFT instead of IPS. Now it still worked in the Pico ZX, but all the colors were inverted. You also need 50 7mm tack switches. Now I recommend getting the ones that are rated at 100 GF. This means that it takes 100 grams of force in order to activate the button. The cheap tack switches that you buy off Amazon are usually going to have a higher GF rating and they'll be harder to press. But 100 GF switches feel really nice for the keyboard on this device. For storage, the Pico ZX uses micro SD cards, so you'll need to pick up one of these micro SD card slots. They're not very expensive. I picked up a 15-pack from Amazon for $8. For powering the device, you'll use an 18650 lithium-ion battery. These are rechargeable and you can actually charge the battery directly in the device. Now, I recommend picking up the version that has a built-in overcharging protection circuit inside the battery. And to charge this battery, you'll need a charge controller. The one to get is the TP4056, which is a pre-built module that you can solder straight onto the board. I picked mine up as a 12-pack from Amazon for only $9. And of course, you'll need a battery terminal to place the battery in. I got this one from Amazon as a 12-pack for around $9. Now, you'll need to be able to power the unit on, so you'll also need this specific power switch. This one was 50 cents from Mouser. For sound, you have the option of either a piezo buzzer or a speaker. Now I went with a thin 8 ohm speaker, which I had left over from last year's Game Badge workshop at MGC. We'll also need a few surface mount components. First, there are 4 10 ohm and 1 4.7 kilo ohm resistor, which is needed for the LCD backlight. A 0.1 microfarad capacitor is used as a voltage stabilizing cap, and a 10 microfarad capacitor is used for the speaker. We'll also need a Schottky diode, which prevents the power from backfeeding into the battery if you have the Pico plugged into USB. There's also 2 BSS 123 MOSFETs. One of these is for the LCD backlight and the other for the speaker. And one BSS 84 MOSFET, which is also used for the speaker. Oh, and of course we can't forget the Raspberry Pi Pico. I'm just using the standard non-Wi-Fi version since this project doesn't really use the Wi-Fi chip. Okay, we'll start the assembly by first soldering on our surface mount passives. First, the 4 10 ohm resistors, which go in this spot here. Soldering surface mount components is actually quite a bit easier than you might think. In fact, I prefer working with them over through-hole parts. The trick is to place some solder down on just one of the pads. Then, while holding the soldering iron in your dominant hand, heat up the pad with the solder, and use your other hand with tweezers to bring the part into the melted solder. Then, you just move the soldering iron off the pad and wait a moment for it to cool down. And then just tack down the other pad with a little bit of solder. Next, we have the 4.7 kilo ohm resistor. One of our BSS 123 MOSFETs goes here in this spot. Okay, these 6 components make up the LCD portion of the circuit. These 3 sets of pads next to it should remain unpopulated for now. We're going to use those later when we build out the full version of the board. Now, if we go over to the other side of the board, we'll populate the components for the speaker. First, the 10 microfarad capacitor. And then the 2 MOSFETs. Now these are labeled, and it's important to make sure that you don't get them reversed. When I first did this build, I accidentally got them mixed up and ended up smoking one of the MOSFETs as a result. Next, we'll solder in our 0.1 microfarad capacitor over here by the microSD card slot. And finally, our Schottky diode goes over here near the side of the board. Now, since this is a diode, you need to make sure that the polarity is correct. The side with the line is the cathode, so that goes on the top side of the board. Okay, next we'll mount the microSD card slot. These pins are kind of close together, so I'm going to put down some flux to help reduce any bridging. And then we can go ahead and attach our Raspberry Pi Pico. What I like to do here is put a piece of double-sided tape onto the Pico so it stays in place while I'm soldering it. Next, we'll flip the board over, and you'll notice that there's a notch cut out in the top of the board. You'll need to solder the test points here on the Pico to the two pads on top of the board. You can use some wire if you want, but I'm just using some leftover leads that I've clipped off from through-hole components. Now we can insert the power switch and solder that into place. And now the fun part, soldering on the 50 buttons. Now there's no special trick to this part. You just insert each button, flip the board over, and solder it in place. You do want to make sure, however, that the buttons are flat against the board when you solder them. Otherwise, the faceplate might not sit flush on the device. I also recommend doing just a few buttons at a time. If you insert all the buttons and then solder them all, you may very well miss some. Alright, next up is the speaker. To hold it in place, I just used some double-sided tape. Okay, the last piece on the main board is the LCD. I saved this for last so it wouldn't get scratched up or broken while soldering everything else in place. You'll notice that there are 4 small holes in the PCB surrounding the perimeter of where the LCD sits. And you'll notice that there are pegs at each corner on the back side of the screen. These will drop into those holes to make sure that the LCD stays aligned correctly. Now we'll need to solder the ribbon cable onto the LCD connector. First, I'll put down some flux. I'll also gently bend down the ribbon cable so it'll make contact with the pins on the board. Next, I'll use a little bit of Kapton tape to hold the ribbon cable in place so it's flat against the board. And to solder it, I'm using just a tiny bit of solder on the tip of my iron. And I'm just going to work my way down the connector in an outward wiping motion. Before moving on, I'm going to use some more double-sided tape to stick the screen to the board so it doesn't flop around. Okay, we can go ahead and set the main board aside and get out the bottom plate. And here, we'll solder the battery charging module onto the board in this spot. All you have to do here is line it up and flood the 6 pads with some solder. I'll also flip the board over and add a little solder into the bottom side as well, just to make sure we're getting a good connection. Now we'll grab a battery holder and solder that onto the bottom side of the board. Finally, we need to connect the power board with the main board using 2 short wires. We'll solder the wires onto these 2 pads here. And the other end of the wires connect to these pads on the main board. Make sure you connect the battery to 5 volts and ground to ground. Okay, this is all the soldering that needs to be done. But before we can turn it on, we need to flash the Pico with the emulator. You'll need to head over to the GitHub repository for the ZX Spectrum emulator by Fruitbat. Once there, you'll grab the UF2 file called ZX Spectrum Pi Computer ZX LCD.uf2. Then you'll want to plug the Pico into your computer and hold down the boot select button on the Pico while flipping the power switch on. After you release the boot select button, the Pico will connect to your computer in UF2 mode and it will show up as a USB drive. Then you'll just need to drag the UF2 file that you downloaded into the root of the drive. After a couple of seconds, the Pico will reset. And if all went well, you should be greeted with the ZX Spectrum startup screen. And we can test it out by dropping into BASIC and writing a quick test program. Everything looks like it works, so let's close it up with the side pieces and a few M2 standoffs before continuing. Now for the slim build here, I found that 4mm standoffs on the front and 5mm standoffs on the back work out the best. We also need to go ahead and prepare a micro SD card in order to load up some programs. We'll need to create a ZX Spectrum folder in the root of the card, and then create a subfolder for tapes and snapshots. And we'll need some tape files in the tapes folder. The Pico ZX supports tape files in either the .tap or .tzw format. We'll then insert the card into the Pico ZX and turn it on. Okay, let's play a game. First, we'll open up the tape loader, and to load a tape, you need to press the menu button, and then that takes you into a menu screen for the emulator. And then we can go into option 2, which is the tape player. And then select tapes, and choose the tape that we want to load. When you exit the menu, the tape will start playing, and the loader will load it up. It loads the tape just like it would on an actual Spectrum. So this process will take a couple of minutes, and is probably a bit nostalgic for some of you. One great feature of this device is the ability to do quick saves. So once a game is loaded up, you can hold down Shift and press Menu, and it'll save the state of the machine to the SD card. Once it's saved, you can quickly load the state by going back into the menu and then using the Snapshots option to restore it. For the joystick, you'll notice that the device has some directional buttons here on the upper left. And there's a fire button here on the upper right. The most common option with games will be to use a Kempston joystick interface. So to put those buttons into Kempston mode, you hold Shift and then press the Kempston button here on the right. And I have to say, for bare tack switches, this doesn't feel bad at all. Alright, well, this is already a great device, but we can make it even better by adding the components to make it the full version, to add external audio, VGA output, and joystick support. We're going to need a few extra parts for the full version. First, we'll need a female DE15 connector for the VGA port. For the joystick port, we'll use a standard male DE9 connector. The full version also adds external audio, so we'll need a 3.5mm audio jack as well. Now this one is just a little bit small, but I think we can make it work. There's also a spot on the board for a USB-B port. Now all this does is it gives you an additional way to power the device. It doesn't charge the battery or provide any data exchange, so it's completely optional. And the last port that we'll add here is a USB-A connector. I'll show you what this is for in a few minutes. We'll need some additional passive components as well. For the VGA signal, we'll need one 82 ohm resistor, 3 470 ohm resistors, and 3 1 kilo ohm resistors. And for the external audio jack, we'll need a 0.1 microfarad capacitor, another 82 ohm resistor, and a 4.7 kilo ohm resistor. Okay, I've taken the device apart and removed the power board. I'll start off with the 470 ohm resistors for the VGA signal. And then the 1 kilo ohm resistors. Next, the 82 ohm resistors for the VGA and audio jack. The 4.7 kilo ohm resistor, also for the audio jack. And finally, the 0.1 microfarad capacitor. Next, I'll mount the USB-A port. Then, the audio jack. As I mentioned, this version I bought is a little too small, but I think we can reach the pads with a bit of extra solder. And the DE9 joystick port. Followed by the DE15 VGA port. and lastly, the optional USB-B port. Before sandwiching it together, we need to solder the power plate back on. And when putting this all back together, we need to use some longer standoffs at the top side of the device. So here I'm using 18mm standoffs on the back side of the board and 4mm standoffs on the front. For the bottom, we'll just use 4mm standoffs on the front side and 5mm standoffs on the back, just like we did with the slim version. I'll screw the faceplate on first with 4 M2 screws. Then I can flip it over and place in the side pieces. And we'll be sure to use the top edge piece that makes room for the new ports. And I'll close it up with 4 more M2 screws. Okay, that's the full-sized version. It's a little bit thicker, but it came together nicely. Let's take a look at some of the features of this thicker version. We'll start off with the one that I think is the main benefit, VGA output. By default, the Pico ZX uses the built-in LCD, so to get it to use VGA instead, you just need to hold down the fire button while turning it on. Everything else works exactly the same. You can still use the keyboard and joystick buttons, and the audio still comes out of the built-in speaker. Okay, let's try external audio. For that, I'll just plug in the speaker that's attached to my monitor. I'll load up another game here, and yep, I can hear the tape sounds coming through the external speaker. But it's also still playing through the built-in speaker. And the game sounds are coming through both the external speaker and the built-in speaker as well. Well, this is somewhat disappointing because I was really hoping I could plug in a pair of headphones and be able to take this device and play it on a plane or in some other public space. But honestly, this could be my fault because, as you saw, my audio jack was too small, it wasn't the right footprint, and I didn't even look to see if it had a disconnect switch in there, so it could just be the wrong audio jack. But it's something to be aware of as a possible issue that you might encounter. Alright, next let's try the joystick port. I have an Atari 2600 joystick here, and that should work with the Kempston joystick support that's built into the emulator. And as you can see, the joystick works great. Finally, let's look at this USB port that's labeled USB host. You can actually use this to connect a USB keyboard or a USB joystick. I've plugged in my wireless Logitech keyboard here, and as you can see, I can now use a full-size external keyboard with the Pico ZX. Okay, let's try out a USB gamepad. I have here a Hyperkin gamepad that resembles an NES controller. I'll just plug this into the USB port, and we'll choose to use a Kempston joystick when we start a game. And as you can see, the USB controller also works really well. All right, we could stop here, and this would be a pretty awesome device to go build. But remember how I said at the beginning of this video that this device has a couple of tricks up its sleeves that make it even more interesting. So let's turn our attention to an open source project called MCUME, the Multi-Computer Machine Emulator. This project is focused on porting several computer and console emulators to various microcontrollers, including the Raspberry Pi Pico. And as part of this effort, the contributors have added support for the Pico ZX. Now this is really cool because it opens it up to emulators beyond just the ZX spectrum. Currently, there are 9 emulators that MCUME has working on the Pico. I've tried each of them on the Pico ZX, and while I was able to get many of them working, there were a few that I could not get to function. And they each have their own nuances. For example, the Atari 2600 emulator plays okay, but there's no sound. But I have to say, my favorite, and the one emulator that I've by far been spending the most time with, is the Commodore 64. Now, not every game is working, but many of them do seem to function just fine. To install the C64, or any of the MCUME emulators for that matter, you need to download the UF2 file from their GitHub. Then, plug the Pico ZX into your computer via the USB port, and hold down the boot select button while turning it on. It should then show up as a removable drive, just like earlier when we installed the ZX Spectrum emulator. And then just drag and drop the UF2 file into the drive. When the Pico starts up, you should see a screen that just says C64 emulator at the top. This is because we don't have any program images on the micro SD card yet. But when you're at this screen, you can press the Fire button, and it'll launch you into C64 BASIC. And now you have a handheld C64 that you can program on the go. If you want to use any games or programs, you can load them onto your micro SD card as PRG files and put them under a folder called C64. Then, when you turn on the Pico ZX with games on the card, it'll list them out on the menu screen. Select the game you want to play and press the Fire button. When it loads up the BASIC prompt, you need to press the menu button to start the game. The MCUME emulators also support VGA output. You just need to plug in your monitor and hold the up button while turning it on. And then you should see the menu screen come up on your external display. As cool as the MCUME emulators are, you should keep in mind that there are a lot of features missing. For example, there's no way to control the volume level, external joystick support doesn't work, and I can't seem to find the delete key in the C64 emulator. But these are all software issues that someone could fix over time. Well, I'm really pleased with this project. I think it's just a really cool device, and it wasn't that hard to build. So if you want to build one of these yourself, head over to PCBWay and buy a set of the boards. The links are in the description below. And if you made it this far, thanks for watching. Hey, I'll see you next time. But until then, go make something cool.